Hello. We are looking at in this section. This section's split into two parts really. This topic, stuff to do with algebraic fractions, and then we're going to look at mathematical proofs later on. But now for this part, we're going to look at algebraic fractions. So algebraic fractions, then, very simply. Well, for example, uh, this is an algebraic fraction, and that's because we have algebraic or terms of x, right? On both parts of the fraction, right? Um, and so what we call that then is a rational function. Well, obviously, if we called that f of x, it would be a function, right? So that'd be a rational function there. So a rational function or rational expression is simply a polynomial of x on both the top and the bottom. So p of x over q of x, right? Where they're both polynomials of x. And obviously, as a reminder, a polynomial is just an expression of x like this. So we have like x to the n add x to the n minus 1 and so on. So this will be a degree of n, okay? And then we have plus x squared plus x plus 1. And you can also coefficients on all the terms. So that could be like an, that could be an minus 1. Need to make more room here. Add a 2. Okay. So that's a very, very general definition of a polynomial. And then also we call the degree of a polynomial the highest power of x. In this case, it'd be n. Okay, and an important thing to note that is that if we had, say, x to the minus 1, that is not a polynomial because it needs to be a positive integer, right? So the last part will always be a constant, okay? It doesn't go beyond that. Anyway, so that's a polynomial. And so we have two polynomials of x on the top or the bottom of a fraction. That's a rational function or rational expression, okay? Very simply, two polynomials of x on top and the bottom, okay? And so then what we'll be looking at firstly is simplifying these sort of rational functions is algebraic fractions. So as an example first with numbers, let's say we have 6 over 2. Now we can simplify a fraction, think back to GCSE, by looking at numbers that go into both the top and the bottom of the fraction, so the numerator and the denominator. And so numbers that go into both, obviously we call them common factors. So factors are numbers that go into two numbers. And in this example, we can see that 2 goes into 6 and 2, because then that's the same as 3 times 2 over 2 times 1. Right, so there we are. And so what we have then is we can simplify a fraction down by cancelling out any numbers that go into both. So 2 is common on the top and the bottom, so I can cancel that out, and then I'm left with 3 over 1, which is just 3. Another example, 8 over 6. What number goes into both the top and the bottom? Or well, 2 I can spot, right? So I can split that to 4 times 2 and 3 times 2, as that would give me 8 at the top and 6 on the bottom. So 2 goes into both the top and the bottom of the fraction, right? And again, because now 2 is common to the top and the bottom, I can cancel it out to be left with 4 over 3. And so we can simplify the fraction in that way, and working with smaller numbers makes it a lot easier to do some maths with it, right? But that should be a GCSE recap. Why am I bringing this up then is because we can do the same with algebraic fractions, right? So if I have x plus 1, x plus 2 over x plus 1, x plus 3. So as the brackets essentially together, meaning the times together, we can write this a bit more clearly as x plus 1 times x plus 2 over x plus 1, x x plus 3. And now hopefully you can see, well, x plus 1 is a common factor, a common term to both top and bottom, so I can cancel that out. And then I'm left with x plus 2, x plus 3. Cool. And we call this simplifying fractions, okay? And that's what we'll be doing in this section. Should be fairly straightforward from GCSE. The idea that we're going to seek common factors that go to the top and bottom parts of the fraction, then we can cancel them out to simplify down the fraction. As obviously a simplified fraction, smaller numbers, smaller terms, makes things a lot easier to work with. Okay, cool. So we jump to some examples. So we have the example here. We need to simplify these. Okay, so this looks a bit menacing, but let's go with it. Part A, we have 7x to the 4 minus 2x cubed plus 6x over x. I notice x is at, well, I could then factorise x on the top, because x is in every term on the numerator here, to get 7x cubed minus 2x squared plus 6 over x. And I will notice a common factor, a common number x is on the top and the bottom. So I can cancel that out to be simply left with 7x cubed minus 2x squared plus 6, okay? And there we are, that's the idea, right? Now, as we just seen there, sometimes they won't actually spell out all the factors and stuff we need to consider to be able to easily recognise the factors that we need to cancel. So you might need to factorise the top and the bottom, okay? So that is the whole idea, is to factorise if necessary, to then spot if there's any common factors on the top and the bottom we can cancel out, okay? So let's proceed. Part B, we have x plus 7, 2x minus 1 over 2x minus 1. So again, what I can spot 2x minus 1 is common to the top and the bottom, common factors. So I can cancel that out to be left with x plus 7. There we are. Cool. Okay, so then part C, we have x squared add 7x add 12 over x plus 3. Okay. Well, again, we don't really have it. Well, we have the bottom as a nice factor, x plus 3, but not the top. Right, it's just quadratic term, right? So I need to get it into factors to see what I can cancel down. Well, I know how to factorise a quadratic, don't I? So I'm going to do that down here. This quadratic x squared plus 7x plus 12. I want to factorise it, but I know how to factorise. I looked at doing that earlier on in the course in GCSE. So how we're going to do that then is we're going to look for two numbers at times to get positive 12 and add to get positive 7 there. So to do that then, we need to consider the factors of 12. So you've got 12 or 1. Do they add together or take away to get 7? No, because either 13 or 11. What about the other factors, 6 and 2? 6 add 2 is 8, 6 take away 2 is 4. We're not going to get 7 from that. What about then the other factors, 3 and 4? Yes, because I can spot 4 add 3 gets me 7. So there we are. Therefore, then my factors, because 4 times 3 would then be 12. Add them, you get 7. Cool. So that's my factors. So for x plus 4, x plus 3. And there we are. We've got my factors. So then I can bring that into the fraction up here to then get x plus 4, x plus 3 all over x plus 3. And what do you know? Now I can spot a common factor to top and the bottom, x plus 3. And I can cancel that out to then be left with simply x plus 4. Cool. Okay, part D, we have this fraction here, x squared add 6x add, what was it? 5 all over the other quadratic, x squared add 3x minus 10, I believe. Yes. Okay, so again, I can't spot the factors right away, so I need to factorise, okay? So the idea is to factorise whenever we can to get it into factors to cancel. So I'm going to need to factorise both the top and the bottom as they're quadratics, but again, I know how to do that. So if I do that down here, let's do the top numerator one first. So we're going to factorise this. So again, I need to consider the factors that times to get 5 and two numbers that add to get positive 6. So we're going to consider the factors of 5, well, they're only 5 and 1, okay? And again, I notice they add to get 6, so there we are. So those are my factors to be x plus 5, x plus 1. There we are. But then we need to do it with the bottom as well. We need to factorise the bottom quadratic. So if we have x squared add 3x minus 10 over here. So I need two numbers at times to get minus 10 and add to get positive 3. So again, I'm going to consider the factors. I'm going to consider the factors of 10, okay? I'm not going to worry about the negatives with this. So 10 will be 10 and 1, firstly. Does that add or take away to get 3 in any way? No. Either 9 or 11? No. What about 5 and 2 then? Yes, because I can spot 5 take away 2 will get me 3. There we are. Okay, but then I need to so that would be my factors, but then I need to see what sign which of 5 or 2 do I need to make negative, because here I need to times to get negative 10. So then 5 take away 2 will get me 3, so minus 2 I think I should take. So then 5 times minus 2 will be minus 10. So those are my factors there. Cool. So then I can bring all these factors that I've got, the factorizations, into my fraction. So the top one here, the factors were x plus 5, x plus 1. All over the bottom are the factors there, x plus 5, x minus 2. Okay. And then again, I can spot x plus 5 is common to the top and the bottom. So I can cancel that out to be left with x plus 1 over x minus 2. And there's no further common factors there, so that's the simplified fraction. Cool. Then we got the last part here, part E. We have this one, 2x squared plus 11x. Plus 12 over... what was it, x plus 3, x plus 3, x plus 4? Was that it? Yes, okay. Okay, so let's go back to here. Well, again, the bottom, again, quite nicely the factorised for us already. But then I need to find the factors of the top part, right? The numerator, the quadratic on the top. So again, I need to factorise. So if I have 2x squared plus 11x plus 12 that over here, I'm going to factorise it here. Well, again, we can't just consider two numbers at times to get 12 and add 11, because we have a coefficient now on the x squared that's bigger than 1, it's 2. What I need to do instead to adjust for that is to times 2 by 12. So as I times it by 12, I then need two numbers at times to get 24. Okay, remember we did that when we looked at factorising in the first chapter actually of the course. And again, we add to get 11 there, okay. So again, to help with that, consider the factors of 24. So we either had 24 and 1. No, they were add or take away to get 11 in any way. What about then 2 and 12? Well, 12 had 2 is 14, take away 2 is 10. That won't give me 11 in any way. Then 3 goes into it. 3 and 8, I believe. Yes, I'll spot 8 plus 3 gets me 11. So that will be the factor that I need. Okay, but in this case, again, it won't be just x plus 8, x plus 3, because if I expand that, I get x squared plus dot dot dot. I don't get 2x squared. What that tells me instead is how I can split up the 11x, okay, because I know that these two numbers will add to get 11. That's the whole idea. So I can split the 11x up to 2x squared, add 8x, add 3x, add 12. So I've not changed the quadratic in any way. That just tells me the way to split up the 11x. And the beauty with this is that, and this will always work, again, we discussed this when we looked at factorising, we can factorise the first two parts and the last two parts, and they will be able to get common factors. Anyway, if I factorise the left part, the first two terms, it'd be 2x of x plus 4, so I can bring 2x to both sides. And then to factorise the second part, 3x plus 12, 3 is the common thing I can pull out. So 3 then of x plus 4. And what do you know? X plus 4 is now common to both terms. So I can factor that out to then get x plus 4. And then I can say 2x and then add 3. And that is my factorisation there, okay? And that will always work again. If you follow that method, you will always be able to factorise eventually in this way. And also I guess to note as well, again, just as a recap, it doesn't matter which order you pick first. You could have 3x plus 8 instead and factor that way. It will still get you the same result, okay? Anyway, those are my factors. So then I get, if I bring that to the fraction, then I get x plus 4 of 2x plus 3, and then I have the given x plus 3, x plus 4, and now I notice x plus 4 is common to top and bottom, so I can cancel that out to be left with 2x plus 3 over x plus 3. Cool. There we are. So that's my factorisation there. So if you spot what the idea is, to spot common factors or terms that are both the top and the bottom of the fraction, to cancel that out, like with normal numbers, right? I can cancel out common factors. And if I don't have factors, then I need to factorise, okay, to simplify it down. But there we are. So we're going to look at one example, fairly short video, not much to this. But let's have a look at this one then. From this exercise, we are given that 6x cubed add 3x squared minus 84x over 6x squared minus 33x plus 42, and it's equal to this fraction here. And I notice it's simplified, okay, because it's less like there's no x cubes or anything like that. It's into factors, right? I can spot that. So I need to simplify it down, essentially. But I know how to simplify it down because I need to factorise and then cancel out common factors, just like we've just been doing, right? So, well, none of the top and the bottom are factorised, unfortunately, so we need to factorise it both the top and bottom ourselves in order to do that. So we're going to do the same thing. So we're going to factorise the top part first. 6x cubed plus 3x squared minus 84x. Well, actually, no, it's x is common to both sides immediately. To all the terms, sorry, not both sides, so all the terms. I can pull an x out to get 6x squared and 3x minus 84 there. Okay, cool. I also can pull out a 3 actually to make it easier for me, because 3 is common to 6, 3 and 84. 84 divided by 3 is actually 28, so I can pull a 3 out as well, just to make the numbers smaller to work with. Well, that'd be 2x squared, right? Plus x minus, then 84 divided by 3 again is 28. And there we are. Cool. So then I can't factorise immediately. I can't spot any factors. I can factorise. So I'm going to need to factorise the quadratic, right? If I can. So let's write the quadratic part then and see if we can factorise this bit. Well, again, the number in the x squared, the coefficient 2 is not 1. So again, we need to consider two numbers at times, not 28, but 2 times 20. Wow, minus 28 times 2 to then get minus 56, not 28. So I need to double it and then add to get 1, right? Because the coefficient on the x is 1. There we are. So that's the same idea then. to factorise. So then to consider this, then we need to find the factors of 56 that will add in some way to get me 1. So again, ignore the negative, let's just consider 56. The factors are either 56 or 1. What about 2 then? 56 divided by 2 is 28. That won't add or take away to get me 1. Either get 30 or 26. Nope. What about 3? 3 won't go into it. 4. Yes, you get 4 or 14. If I add or take them away, I either get 18 or 10. I'm getting closer to 1, but not 1. What about 5? Nope. 6. Does 6 go into it? Nope. What about 56 divided by 7? Yes, then 7 and 8. And I notice I can take them away to get 1. So that is my factor pair there. But again, this won't factorise into x plus 8, x plus 7. Because I'll already get x squared from it. I won't get 2. Okay, so that is, we can't jump to that. But well, again, that tells me that if they take away, that adds to get 1. Because obviously I can take minus 7 there. 8 minus 7 is 1. So that tells me I can split up the x to 2x squared, add 8x, take away 7x, okay? Minus 28. And then I factorise the first 2 parts and the last 2 parts there. So then I can bring out 2x here to get x plus 4. Then I can factor out minus 7 to get x plus 4 there. And then again, x plus 4 is common to both parts. So I can factor that out. And then I get 2x minus 7. There we are. So then this overall, right, overall, what do I call it? Parts of brackets of x, I don't know. We get 3x, and then this, again, this quadratic we factorise to x plus 4. 2x minus 7, okay? So I could bring that up to here. So that was the numerator, again, remember. So now that has the factors 3x of x plus 4 and 2x minus 7, okay? Cool. Okay, so that's the numerator. Okay, so you can get not the nicest quadratics, but the method's the same, right? You want to factorise it as much as you can. Even if they are not particularly the nicest. Anyway, so then we can do the same to the denominator, right? Factorise the denominator to spot the factors. Do it up here. 6x squared minus 33x plus 42. Okay, so again, I need to find 2 numbers at times to get not 42, but 6 times 42, which is 252. And obviously that's again because we have 6 on the front of x squared, not 1, so we need to adjust for that. Then we need to add again to get minus 33. So again, we're going to consider the factors of 252. So obviously 252 and 1, then 252 divided by 2 is 126. No, what about divided by 3? 84. 3, no, we're getting closer to 33, but if I add or take them away, again I got 87 or 81, no, but we're getting closer. What about 4? 63 and 4, nope. What about 5 won't go into it. 6, 42 and 6, well, we're getting closer now. 42 take away 6 would be 36, not 33, but we're quite close. What about 7? 36 and 7. Nope. So that will either add to get 43 or take away to get 29. But again, we're quite close. What about 8? That doesn't go into it. 9. 28 and 9. God, I have to write it down here. 28 and 9. That will add to get me 37 or take away to get 19. So not 33 though. What about 20? What about 10? Now won't go into it. 11. What about 12? 21 and 12 goes into 252. There we are. That's my factor pair there. Because if I add them, then I get 33. Okay. Obviously, it's not minus 33, but again, I don't care about the minuses. I can adjust for that in a moment right now. But I can add them to get 33 in that way. Okay. But then I need the time to get positive 252 from these two numbers, but I need to add to get minus. Well, the only way that's going to happen, if you think about it, is that if both of these were minuses then. So if I have minus 21, minus 12, that would get me minus 33. And then if I times them, that would still be positive 252. Because two negatives make a positive. So those are my sort of factor pairs there. Okay, that's what we want. Cool. But again, that tells me the way to split up minus 33x. So that'd be 6x squared minus 21x minus 12x plus 42. And again, then I need to factorise the first two terms and the last two terms. That'll be, then I can bring out 3x, I believe, to get 2x minus 7. And then I can bring out for the second part, what number goes into both 12 and 42? Won't be 4, 6? 6 go into it? Yeah, 6 goes into it, so I could, then I can take away 6, and then that'd be 2x, and again that'd be minus 7. There we are. So minus 7 is common to both parts there, so I can bring that out to get 2x minus 7, and then 3x minus 6 there, and cool. Well, actually, I can bring out a 3 in that fraction as well, can't I? I can simplify that even more to bring out 3 lots of 2x minus 7. And then x minus 2. There we are. So those are my factors then. So then I can bring, that's a denominator here. So then I get 3 lots of 2x minus 7, x minus 2. There we are then. So then can I simplify it then? What can I cancel? Well, firstly, at 2x minus 7 is common, but also the 3 there. So actually I'm left with x of x plus 4 over x, let me get rid of this here, x minus 2. And there we are. I can't simplify that anymore. So there we are. Let's compare it with the answer. Well, indeed, that matches what they want the answer to look like. If we then compared, the A part would be 1. B would be 4. And C would be minus 2. If you notice there, and there. And there we are. So that's our answer then. Cool. So yeah, so even if it gets quite gnarly, the idea is still the same, right? To factorise whenever we can to get the factors, which then allows me to cancel out anything common to break down the fraction, which will be helpful because a broken down simplified fraction is easy to work with. Okay, cool. So that's simplifying fractions. We will be looking more about those type of fractions later on in the topic, but for now, I'll see you later.